and this is on page 151, and we have f of t again as 2t plus 1 over t plus 3. So this time we are asked to find f prime of a. You have two possibilities, similar to f prime of x, but replace x by a, or the other one when x approaches a. It's up to you. Since we have used the same definition, f prime of x or f prime of a, several times, let's use the other one when x approaches a this time. Is that okay? So we want to find f prime of a as the limit as x approaches a from f of x minus f of a divided by x minus a. Okay, so let's start. So you understand that this a can be any number, in other words. So if a is indeed given to us like 5 or 10 or 15, then the answer would be just a single number, not a function. So f prime of a would be just one number, which is the slope of the tangent line at the point with x being a. Okay, so limit as x approaches a from, sorry, doesn't matter, but it's t. Okay, so 2t plus 1 over t plus 3 minus 2a plus 1 over a plus 3 divided by t minus a. Sometimes this definition is a little bit more human than that a plus h because it's kind of cumbersome. You're plugging a plus h and etc., right? Okay. Good. All these should have been on the same line, so my apologies. They're not. This, bless you, this step is not written correctly. Good. I'm making it correct right now. Least common denominator in the numerator, please. The product, right? Correct? They have nothing in common, so it must be t plus 3 times a plus 3, correct? Agreed? Okay, so then the top needs to be multiplied by a plus 3 of the first fraction and by t plus 3 of the second fraction. So now I distribute a to 2t, 2at, a to a 1, 3 to 2t, n plus 3. But now very carefully, everything gets a negative sign. Everything is positive, so everything will change sign. Negative 2at minus 6a minus t and minus 3. I'm hoping that a lot of terms will go away. And negative 2at with positive 2at. Negative 3 with positive 3. I didn't say let's plug it in because we already know it's 0 over 0 from the very beginning to find the limit. So this is limit as t approaches a. The numerator, look at what happens here. 6t with negative 6a and negative t with positive a. I see, by the way, what am I trying to get rid of? Which one is the culprit that creates 0 over 0? Of course, t minus a. T minus a is the problem. T minus a is the problem. So I'm trying to see if I can factor the top, factor out the t minus a. So I will write 6t minus 6a minus t and plus a in this particular order. And this is t minus a over 1, so I flip, so I have t minus a, t plus 3, and a plus 3. Let's see if this is clear so far, please. Is this okay? So one more time. I copied 6t and minus 6a, and I copied negative t and positive a. But then I have to flip this. It's 1 over t minus a, and then t plus 3, and then a plus 3. Is that okay? Is it a yes? Okay. So now the numerator, I see 4 terms, and here's my hint. What am I trying to say? Factor by grouping. Good. What will you factor out from these two? What should I factor out from the other two? I refuse to look. Very good. Now I can look confidently, because otherwise who knows what I come up with. And then I can continue. So then what should I put in front? Very good. So then t minus a, t plus 3, a plus 3. Obviously, in the numerator, I should have combined them. Now I realize that there is no need to do that. Thank you. I don't have to do that. Sorry about that. So 6t minus t is directly 5, and negative 6a plus a is still negative 5t, 5a. So there is no need to do that. So you can skip this step. I'm so sorry. Okay, so this is limit as t approaches a. Indeed, 5 t minus a. And then t minus a plus 3, and t plus 3. And yes, finally, and now I can drop the limit operator. So when you redo this problem, please just write 5t minus 5a here instead of all this. There is no need. It's not wrong, but there is no need. This is much easier. Okay. So can anyone give us the final simplified form of f prime of a for this particular function? Excellent. You mean a plus 3, because t approaches a. That's okay. Very good, indeed. T approaches a, so it's 5 over a plus 3. The derivative function will be indeed 5 over t plus 3, and you can square it, and you can replace t by a. That's fine. Any questions? Any questions? So 5 over a plus 3, everything squared. Is this okay? Okay. I'd like to look at this problem for a minute. It says, for the function g whose graph is given, arrange the following numbers in increasing order and explain your reasoning. So ready? So g prime of negative 2. So this is negative 1 and this is negative 2. I am going to draw a tangent at negative 2. I'm going to form a triangle. I'm going to say complete estimate. Complete estimate. I'm going to say that this is 2 over 1. So I'm going to say that this is 2. Then g prime of 0, I'm going to draw a tangent at 0. I'm going to say, kind of looks like a 2 over 1, but of course a negative 2. Then a g prime of 2, again, I'm going to say, I don't know, this is not as steep. So this is steeper than this. I don't know. I'm just going to say 1 and 2. So it's 1/2. And the g prime of 4, I'm going to do this. I don't know. I'm going to say 1 and 3. So I'm going to say 1/3. Definitely this is much steeper. This is much steeper than this, which is, and this is smaller than this. So I think that this is definitely bigger than this, and this is definitely smaller. So the biggest, next in line positive, and next in line positive. And then this is a negative number. So this is my estimate. So for g prime of 4, I would say 1/3. For g prime of 2, I would say 1/2 for this negative 2 and for this 2. So the order is from left to right. So it says in increasing order, negative 2, 1/3, 1/2, 2. It's a rough estimate, but the order is correct. I hope you agree. Do I really know that this is 1/3, and do I really know that this is 1/2? No, I don't. But I created all these triangles just to come up with an estimate and see which one is steeper. Okay? Good. So what else? Yes, I like to look at something like this to further understand what's happening here, and especially measurement units. Okay. So we're going to talk about oxygen. I should have asked you. So the number of bacteria. We want to talk about the number of bacteria. So the number of bacteria after t hours. Let's start with that, and then we can look at anything else. So the number of bacteria after t hours in a controlled lab experiment is n. So n is the number of bacteria, but it's also a function of time, f of t. N gives us the number, but f of t is the function at time t. And t is in hours. What is the meaning of the derivative f prime of 5? The rate of change. So remember, f prime is the rate of change, it's the slope of the tangent line. So at 5 hours after the experiment starts, we know what is the rate of change of the number of bacteria with respect to time. So what would be the measurement unit? It's a rate of change has to have 2 measurement units.
Bacteria per hour.
Number of bacteria per hour. Excellent. Suppose there is an unlimited amount of space and nutrients for the bacteria. Which do you think is larger? Unlimited. They can blow up. Unlimited. Okay. Which one would be larger, f prime of 5 or f prime of 10? Yes. Right? We agree? Because they are going to start multiplying so fast that f prime of 10 will be higher than f prime of 5. After 5 hours, it will be, I don't know, 20 per hour, and I'm just making up numbers. And 10 hours later will be 5,000 an hour, because it's unlimited. I have unlimited space and resources. If the supply of nutrients is limited, would that affect your conclusion?
Yes.
So here's why. Let's say we invite as many people as possible into this room. After the first minute, they come in fast. After this 20 minutes, slower. After an hour, even slower, because there is no more room. So at first there is room, and they come in fast. But then after a couple of hours, we just have to push them in because there's not enough room. So yes, which one would be larger if the resources are limited? f prime of 5 would be faster, higher rate than f prime of 10. Okay. Any questions? Any questions? I would like us to look at the graph now. We're given a function. We're given a function. So here are some options that I would like to you choose. I will let you choose. We're given a function. We're asked to graph its derivative. One option. Second option. The graph of f is given. State with reasons the numbers at which f is not differentiable. So we can work on that. The graph of a position function of a car is shown, where s is measured in feet and t in seconds. Use the graph of the velocity and acceleration. Use it to graph the velocity and acceleration of the car, which is the same thing with something like this. So we're asked to find the derivative. So maybe I should say that first. And let's put it in writing. So if we're given a function like s of t, distance, how do I determine the velocity? Which is yes, s prime of t or v of t will be the rate of change of distance with respect to time, which will be the velocity. How do I determine the acceleration? The acceleration is a of t or v prime of t or s double prime of t. So the acceleration is the first derivative of the velocity or the second derivative of the distance. In order to determine the velocity, I have to differentiate the distance. In order to determine the acceleration, I have to differentiate the distance twice. We don't have differentiation rules just yet. We will start them in chapter 3. In chapter 3, we will not need to go back to the definition of derivative f prime of x equals the limit s of the difference quotient, because we will learn how to differentiate using differentiation rules. Yes, I know you're very happy, Jeff. Thank you. Okay, so what if let's start with a semicircle. What do you think about that? Is that okay? You don't want to start with the semicircle and graph? So we are given the function, and we would like to graph the derivative. It's going to be a rough estimate of the derivative, but it will be interesting. Any questions? Any questions? Are we okay with that? You want to pick another function? Or you want to start with a circle and then pick another? Yes? So this is these are here notations. We're going to talk about these notations when we need them. Right now, there is no need. Not at this point. But I'll show you the Leibniz notation, and all these definitions will come into play. Okay, so you want to start with something, or you... Yeah, 7 is fine. Okay, so let's start with 7, and then we can choose another if that's what you want. And I would like to start reviewing. Okay, so here's the graph. Please leave enough room immediately under this graph. So this is the function. And right here in a different coordinate system or Cartesian system, exactly under, immediately with the same vertical y-axis, I would say. So we can use the same points. Okay? Ready? So we're given the graph of a function, and we're asked to come up with a rough estimate of a graph of its derivative. Would you agree that there is a tangent here and a tangent here and it's vertical?
Yes.
Okay, so now I'm going to come up with some numbers. I have no idea, but I know one number for sure. What is this number? Exactly, the slope of the tangent line at that point is indeed 0. Also, I know for sure that all these tangents on this side are all what? Positive, right? And I know that all of them on this side are definitely. So this part will be on the positive side, and this part will be on the negative side. Agreed? Okay. I'm going to have to come up with some numbers. Again, I don't know. I'm going to say 1. Definitely smaller. Here, definitely bigger. And I'm done with this side. Since it's symmetric, I don't have to do anything to the other side. And this is f prime. You do have this handout, right? Everyone? Eric, are you tired? I know you're tired. I know you're tired. I know. So let's, enough of this, and we can go back to other problems later. Let's go over this, whatever you want. We do not have to go over this because it's the problem from the quiz. We do not have to go over this because it doesn't belong here. We do not have to go over this because we already finished it. And now choose anything else. Anything you want. Which one? 2E. 2E. No, we just did that yesterday, the other day. It's the same problem. If you want me to do it again, I will. It's not the same?
It is.
Okay. Okay. Anything. I'm missing a 1 here. My apologies. Please put a 1 in here. Good. So what would you like to start with? Our test is a week from today. And we're hoping to finish the review today and 1 hour on Monday so we can continue with chapter 3. Are you okay? Please tell me what you would like to continue with. Anything.
How about 2D?
2D. 2D. Let's start with 2D. 2D. Very good pick. See, I told you this is our first love and second love. Square root. Thank you. So this is limit as x approaches 2 from the right from the square root of 4 minus x squared. Okay. First, the problem is asking us to find the domain of this function. Ready? So forget about the limit for a moment. We are only interested in finding the domain. So disregard this for a moment. We have a function that is the square root of 4 minus x squared, and we want to find its domain. So what do I have to write in order to find this, the domain of this function? Say it again. Excellent. Perfect. How do we solve such an inequality, and what is it? What type of inequality is this? Thank you very much. Quadratic inequality. How do we solve a quadratic inequality? Say it again.
Solve for x.
Yes, how? What will be the first step here? So, no, we can never take square roots from inequalities, please. So negative x squared greater than or equal to, I meant to put plus 4. Great, never mind. Negative x squared plus 4 greater than or equal to 0. First, I have to multiply by negative 1. I get x squared minus 4 less than or equal to 0. And I have to factor. Please remember, extremely important, do not attempt to take square roots from an inequality, from both sides of an inequality. Please don't. Okay, so keep this in mind. It's my habit. Of course, you should adopt it if you think it's worth it. If you think it's not worth it, then don't adopt it. I always prefer polynomials to be in descending order, and I don't want to see a negative leading coefficient. It's easier to factor, it's easier to handle, everything is easier if if a leading coefficient is positive and it's arranged in descending order. Then I recommend, there are other ways of course, and I accept all of them, but I recommend this little table in which I put each factor separately. And at the very end, what I'm really, really interested in, I'm not interested in x plus 2. I'm not interested in x minus 2. I'm interested in the product of these two. So next, I put at the top of the table, I put the value that makes this 0 and the value that makes this 0. Where is this 0? At negative 2. Where is this 0? Right. So I put them in the correct order, ascending order. I see that there is a 0 here and here. And of course, the product will be 0 if either factor is 0. And now really, I don't have to think why. I don't have anything against the thinking. But both these two have a positive slope. They come from negative and go to positive, which means negative and positive and negative and positive. When I multiply, because this is the product, when I multiply these two negatives, I get positive. When I multiply a positive and a negative, and when I multiply two positives. So obviously, now this will tell me what to pick. Which sign is less than or equal to 0? What should this be to be less than or equal to 0? It should be, where is this negative? Right. So then the domain of this function is between negative 2 and 2. And now I know, and I'm ready to determine the limit. And the limit is, as x approaches 2 from the right, from the square root of 4 minus x squared. Once I have the domain, I can write the final answer. So what do I write? What do you think?
Undefined.
Of course, it's D and E. The function doesn't exist on that side of 2. That's why we needed to determine the domain first. Very good. Excellent. That's what it is. The answer is D and E. That's why I wanted you to determine the domain first, to see that the function doesn't exist on that side of 2. The function does not exist here, and it does not exist here. The same thing if I ask, find the limit as x approaches to -2 from the left, you will still say D and E. Because the function does not exist at all. If it doesn't exist, it cannot have a trend approaching anything. Is that clear? Good. Next question, please choose. Anything else? Let's make a list of topics. Let's make a list of topics that will be on this test. Difference quotient, of course. Limits. Continuity. F prime and F prime of A. You know what I mean. So the difference quotient, limits, continuity. Of course, continuity at a point. Especially that definition. What is the definition of continuity at point? The limit from the left equals the limit from the
Right.
and equals the function value at that point. Okay, vertical asymptotes and horizontal asymptotes, as we just did today, one example, with the limits. Given info about a function to come up with a graph. Graph a function given info, limits, etc., etc. Intermediate value theorem, IVT, squeeze theorem, a numerical example like this, the very first one that we looked at. That was really the first kind of problem. Numerical example for secant and tangent. Given information, find the slope of the secant line and then find the slope of the tangent line.
So for the secant and tangent, that'll like asking using the point slope in order to come up.
Yeah, this example. We're going to work on that in a minute. Epsilon delta definition. I cannot think of any. Oh, yes, piecewise defined function. That's it. I can't think of anything else. So when I said continuity at a point, I mean something like this. When I talk about the derivative and the definition, I mean something like this. Graphing a piecewise defined function, something like this. An example of a graph. And that's it. Now you choose. From this, number 9. Very good. So let's take a look at number 9. Very good. So that's it. I didn't teach you much in this chapter. That's it. Okay, so we have limit of 5x minus 2 as x approaches 1, and they say it's 3. Do not believe it, just check it. And we're asked to use the definition, the epsilon delta definition of the limit, and show. And we have to show both ways. How do I start? So 5 times 1 is 5 plus minus 2 is 3. So for every epsilon positive, I will find the corresponding delta positive such that 0 less than, very good, awesome, in absolute value, very good, less than delta. This will definitely and always and forever imply is less than, that's it. Great job. Good. So the starting point is here for one step. So 5x minus 5 in absolute value less than epsilon. Really nothing. I just factor out 1. You know what I mean. Factor out 5 to get x minus 1 in absolute value less than epsilon. I have to show that property. I have to write this step, mandatory, although we all know what it means and we can skip it, but I have to write it. Then I have to write 5, the absolute value of x minus 1 less than epsilon. And finally, x minus 1 in absolute value less than epsilon over 5, which cannot be, by comparison, anything else but and this is it. And in step 2, I'll say show that delta equals epsilon over 5 works. You do not have to reverse the steps, just write this sentence. Works by reversing the steps from 1. So this problem should take tops 3 minutes. Next question, please. Next question. Yes. Yes. Yes.
Step 1, we had 5x minus 5, the after value of 5x minus 5.
Yes, because we had negative 2 minus, yes.
And then the next step, you incorporate 5 times the actual value.
I factor out. I factor out from 5x minus 5, I factor out 5. Because my target is to get this. If I don't get this, I can't identify delta. So that's my target. So obviously when I saw that, I said, oh, okay, I'm almost there. Because by factoring out 5, I get the x minus 1. Better?
Yes.
Perfect. Good. Next question. Number 7, let's take a look. Yes, in number 7 we have the equation x to the 5th plus 7x plus 5 equals 0. And we're asked to use the intermediate value theorem. So remember our starting point, like the squeezing theorem or squeeze theorem, we have two hypotheses. So the first is that I have to create the function, in this case, x to the 5th plus 7x plus 5, and I have to say is continuous everywhere as a polynomial function. We know polynomial functions are continuous everywhere. And the next step, I have to plug it in the graphing calculator. So in y equals clear if you have anything else. X to the 5th, and then plus 7x plus 5. And then I will just start by, I start simple, I start from 0, and I'm going to plug in 0. And I'm going to plug in 1. I'm going to plug in 2. I'm not going in the right direction, so I'm going to go back to a -1. And I'll say I found where a solution is. Because at 0 is positive, at -1 is negative. So there must be a solution between -1 and 0. Or you can look at the graph. It's not cheating. Just look at the graph and you already see that the solution is definitely between -1 and 0. So I will write, this was the first hypothesis. The second hypothesis, I will say that f of -1 is a negative number. You don't have to copy the value. It's not important. And f of 0 is positive. That's sufficient. In other words, the function is continuous between 0 and 1. It's a continuous everywhere. It's continuous between -1 and 0, and it changes sign. Therefore, by IVT, so by IVT, there exists C in the open interval -1, 0, such that f of C must be, for sure, equal to 0. In other words, C must be a solution, must be an x-intercept, must be a 0 of this function. Questions? Is this clear? Okay. Next question, please. I'm putting the attendance in, and of course I'm logged out.
We did something similar with 2H.
Yes? 2H. Yes, let's do 2H. You want this? Is that okay? Okay, very good. So limit as x approaches -infinity from 3 tangent inverse x plus 2. Very good. Good. So of course we have to plug it in to see what's happening. And please remember the graph of tangent inverse. If you need me to refresh your memory, I will graph it again with pleasure. But if you do remember, when x approaches negative infinity, this piece approaches. Very good, awesome. So negative 3 pi over 2 plus 2 is the final answer. Do you want me to graph it again? Arctangent. Yes? Yes? Very good. Like natural log, like the exponential function, like tangent. Please remember the graph of arctangent. It's a very important function. So this is arctangent x, also denoted confusingly, right? It looks confusing, but please remember they are the same. And this does not mean 1 over tangent. Please do not confuse that. Good. Next question, please. Yes?
That's not a question
Yes.
related to the review, but for inverse cosine,
Yes?
I'm trying to remember the interval that is in between.
Yes, very good. Awesome question. So remember, we have to truncate the domain of all these trig functions because they're not one-to-one. So in order to create the inverse function, we truncate all domains. So for arcsine, the answer has to be, so in pink, this is for arc sine x. For arc cosine x, I'm going to make it in black. It will be this, between 0 and pi. 0 and pi for cosine x or arc cosine x. And the third one that is important is arctangent. I'm going to make it in green. The arctangent is this. Very similar to arcsine, between negative pi over 2 and pi over 2. But without those, because the function is undefined at negative pi over 2 and pi over 2. So this is for arctangent x. The pink is for arcsine with negative pi over 2. So I'm going to put negative pi over 2 and pi over 2, and here pi, and here 0. For cosine between 0 and pi. For arctangent between negative pi over 2 and pi over 2 without those. And for arcsine between negative pi over 2 and pi over 2 with those ending points. So always remember the arcsine with arctangent together except the endpoints, and just cosine the first and second quadrant. So first and fourth, both for sine and tangent, arcsine, arctangent, first and fourth, but for cosine, 0 to pi, because we need both signs. That's why we have to use 0 to pi. Good. Next question. What would you like to do next? Do I get to pick, or you want to pick? Okay, I would like to look at an example like this. So this is our function for a second. Just look at 1 over x plus 1 when x does not equal negative 1. And let's say 5 when x equals negative 1. Can I make this function, can I turn this function into a continuous function?
Not the function.
I cannot because there is a x equals negative 1 is a vertical asymptote. So this function can never be turned into a continuous function because this discontinuity is not what type? This discontinuity is not what type? It's not a removable discontinuity. Good. Awesome. Now I want to give you a counterexample. So let's say I have f of x equals x plus 2 when x does not equal negative 3. Does this function have a removable discontinuity? I don't know. Let's determine the limits. If the limit from the left of negative 3 equals the limit from the right of negative 3, then, and not the function value, this function is not defined at negative 3, not f of negative 3 because it's not even defined, then it has a removable discontinuity at negative 3. Does it? Yes, because this is x plus 2, and this is x plus 2, and this will be negative 1, this will be negative 1, and this one doesn't exist. So will you agree that this function has a removable discontinuity? Perfect. And now I would like us to create a function that is continuous everywhere using what we have, using the function we have. I'm going to call it g of x, and I will write x plus 2 when x does not equal negative 3. I have to use what I have. And what change will you make? What change will you make in order to make this continuous, this function? This one is not continuous at negative 3. But I would like this function to be continuous everywhere. So you have another option here. You're given a second option. What will you say or do or write? So if I put here 5, let's put it. I'm going to delete it in a moment. When x equals negative 3, correct?
Yes.
Okay. So let's see if this function is continuous everywhere, as we claim. The limit from the left is negative 1. The limit from the right is negative 1. But the function value at negative 3 is 5.
Negative 1.
Thank you. Thank you. Excellent. That's all we needed to do. A finite change. One tiny little change to make the function continuous. And of course, we had to create this point. In other words, negative 3 comma negative 1, where both sides limits are the same and equal to each other, of course. So now we created a function that is guaranteed to be continuous everywhere. Yes, please.
We have to solve for x plus 2.
You have to determine those limits. Because now we are saying this. The limit from the left and the limit from the right are both negative 1. And what we did with this, we just filled it in. And now this function is continuous everywhere. How did we fill it in? With the point negative 3, negative 1. Because the limit from this side was negative 1, the limit from this side was negative 1. All we had to do is just fill this in. Better? Good. Anything else? Would you like to work on this? And we can stop after this one if you like. Should we work on this one? Or number one?
Sure.
Or you want to try it first, or you want something else? It's up to you. You decide. On number one? Okay, perfect. So remember on number one, this is what I recommend. This is what I would do right away. I would create my table and the slope. X is the variable in the problem. Yes, of course, it's t, of course. I'm jumping into conclusions. Doesn't matter, of course. So look at the intervals. Pi over 2, pi. Pi over 2, pi over 2, plus a little bit, closer, 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 closer to pi over 2. So obviously, this will be pi over 2. Then the next one closer to it will be pi over 2 plus 0.0001. The next one is pi over 2 plus 0.001. The next one is pi over 2 plus 0.1. And the last one is pi. So this is the furthest away. The next one closer to pi over 2, closer to pi over 2, closer to pi over 2. So I have 1, 2. I skipped one. Sorry. Pi over 2 plus 0.1, and then pi. So I have 1, 2, 3, 4, 5. Of course, I will create the slope of the secant line, which is s of t, obviously minus s of pi over 2, over t minus pi over 2. Because everything, each and every interval has pi over 2 as one end. So all I'm interested in is pi over 2 and getting closer and closer to pi over 2. So I will put this in the graphing calculator and plug in those numbers, starting from further away to closer. But this is the correct order. This is pi over 2 pi. This is pi over 2 plus 0.1 plus 0.01 plus 0.001 plus 0.0001. So these are closer and closer to pi over 2. This is further away. So let's plug it in y equals. Parentheses, please, around the numerator. And I should have asked you before doing this, how much is s of pi over 2? So the function is s of t equals 3 sine t. How much is this? Yes, this is indeed 3. So then what I'm going to plug in is 3 sine t minus 3 over t minus pi over 2. Parentheses around the top, parentheses around the denominator, please. Always. So again, this problem should only take you 4 minutes, maybe. 1 minute to plug it in, and the rest to calculate. So 3 sine x, close the parenthesis, minus 3, close the parenthesis, and divide by, in parentheses, x minus pi over 2. And now what I have to do is just go back and plug in numbers. I'm going to plug in pi first. Then I'm going to plug in pi over 2. And then plus 0.1. Then I'm going to plug in pi over 2 plus 0.01. And then pi over 2 plus 0.001. And finally,
I didn't have pi.
of course I did. I'm very good at that. Thank you. So pi divided by 2 plus 0.001. And finally, pi divided by 2 plus, and I'm going to go as close as possible to see what I get. So I will copy these numbers, and this is it. And what is your conclusion? That the slope of the tangent line at pi over 2 is how much? 0. So I'm going to copy these numbers. So at pi is negative 1.91. And next one, negative 0.1499. And then negative 0.015. And then negative 0.0015. And this is close to 0.